My name is James Lee, and I just now 18 years old, and I like math stuff to calculate stuffs like divisioning and getting decimal point of the numbers. And I'm passionate about security vulnerability research, so I like to look under the hood of the softwares. So we'll look the way of rendering HTML inside Internet Explorer 11. There are lots of ways to render HTML, so we'll go step by step and look which ways are best for discovering vulnerabilities. And there is information disclosure and content spoofing vulnerability I've found. So I briefly demonstrated and the way of finding methodologies I'll be introducing. And there is an application called HTML Help Viewer, which is an application embeds the IE11 feature, so we can exploit through IE11. And finally, I will finish off using local file detection and top frame issues, including universal cross-site scripting and same origin policy bypasses. Okay, so let's start. First thing we can think to render HTML in Internet Explorer 11 is inline frame, of course, and object and even an embed tag, because we can render an HTML inside a frame. But these are visible scripts, so it's not that interesting methodology. And next thing you can think is using an implementation methods. In this case, implementation create document retrieves XML and creates the document with XML document, while implementation create HTML document creates an HTML document, and these are quite similar to XML HTTP request, and we can use XML HTTP request itself to retrieve XML. And final object is ActiveX object. This is some interesting object because we can instantiate the scripts like HTML file and double script shell and lots of other stuffs like Excel spreadsheets, and there are lots of object vectors, and we will look one by one. So basically this, as I said earlier, this document object actually retrieves text XML, and these are invisible scripts that we can render logically, which means you can execute this script as an invisible way, but same functionality as iframe, because it has lots of features we can use as a render HTML, but there is limitations, like these are not associated with Windows, so we cannot use like window.open, and some scripts are limited. So there are some sort of limitation for using these implementation method and others. And of course, the ActiveX object has its limitation too, but these are capable for running scripts, which is we want it for all the time. So basically, we can instantiate this ActiveX object called the HTML file object. We can instantiate invisibly, and this will run ActiveX object script effectively. So, and this returns a reference to its document object. There was a local file detection issue. I've presented this in ZeroCon 2017. Basically, we are using resource handler. This resource handler is, we are loading resources from system32, which is default directory, and there are certain kind of version resources and identifier, and there was 16. This is RT version, and we can load up binary files and DLLs and sort of files. So but MS-HTML had this restriction on adding 16, because if you add a 16, there was a regular expression filter, so we cannot directly add a 16. So I've used some math trick here, using a double quote injection and double backslashes. So Internet Explorer will sync this double backslashes as a normal pass, and it will parse as a 16E0, and E is of course Euler number. So this get like 16 multiplied to e to the power of 0, and it comes to 16. So can bypass it in mass ways. There are two ways to exploit this kind of local file detection issue. As I showed just now, this is some XML DOM version of bypassing. And another way is using inline frame tag and using event handlers such as like onReady state change, because when the state changes, we're using unspecified error and to detect a presence of the file. So effectively we can determine whether we will exploit the user. Certain user has a certain program installed, so it's fingerprinting a user. And next issue was information disclosure. First of all, we are creating a non-content iframe, which has nothing. As you can see here from source, it says haha none exists. This is nothing. And then we are creating script and instantiating ActiveX object window. So basically we are closing, open and closing, and open and closing, which means this will destroy the content of the iframe, which is nothing. But while iframe content is disabled, script itself is alive, which means script will be executed even when you leave the page. Like if you visited some certain page and you move to Facebook or Google page, but the script will be still alive and have a privilege on that page. So can hovering off the information, and the script can be followed over and over, whether you move the site or constantly using another site. So for step for this, using a previous script and using open close trick. And as you can see here, information disclosure, use the resource handler. Use the several Unicodes here and 16 this RT version. And if you create another HTML file from an iframe, now we can use a window open method, which is invisible. So you are able to pop any windows while you are moving to another site in Google, Facebook, others, as I said. And there are pop-up blockers. You can still bypass the pop-up blockers without restrictions. So while you're navigating on a site, these pop-ups will keep pop and hovering off the data. So this is basically information disclosure. So best thing is to play around with this ActiveX object feature and keep messing around with like XML DOM features and other event handlers. And eventually you will get to some kind of this logic design bug. And these are quite fun to play around. And this is the final code. This will open a Facebook page. And as you can see here, it stays to self reference. If we instantiate the self reference in Internet Explorer itself actually thinks it's a top page, which means even though you move to Facebook page, the Internet Explorer actually thinks the Facebook page is top, so we have a full privilege for Facebook page. So it's basically same origin policy bypass 2. And we can also close tab directly. I'm not sure if you can see this well, so I might need to bring on magnifier. Wait a second. Oops. We are referencing to self-reference, and to make the script keep alive, we are giving a set timeout function. So while if you not give a set timeout option, alert will get blocked by UI because we need a script to be executed afterward too, so we can bypass this using set timeout and make a script still alive. And this is a short demo for this. Let's just check it. Basically, we are visiting blog here. And scripts will be executed in Internet Explorer for load, as you can see, and without pop-up blocker, script will be popped from other site. So basically, script is still alive even when you're visiting Facebook, Google, or other sites. And yeah. And next thing is HTML help viewer. As you know, like Internet Explorer 11 is kind of deprecated browser, but still lots of System32 on the application actually uses embedded feature for Internet Explorer. For example, there is something called HTML help executable, and this uses an IE11 embedded feature, and it runs in medium intuitive level, which means it's same as Internet Explorer, but without an enhanced protected mode sandbox. So IE11 version without a sandbox and runs in medium intuitive level, and you can run that inside an application. So if you are able to find the vulnerability inside here, actually we might able to get to like device guard, bypass vulnerabilities, which is user mode code integrity bypassing. Basically, this allows you to execute a unsigned binary as a signed binary, so you are able to execute a signed medium intuitive level binary via unsigned binary, and that's possible. So if you give a comment that's below hh.exe and HTTP site, then this will open a site inside this application with medium intuitive level Internet Explorer. So this is basically running Internet Explorer in Internet Zone, but with medium intuitive level. So I've thought maybe ActiveX controls via HTML would do the trick and can find some fun vulnerabilities in here. So I've started to mess around, and what I found out is I've used WScript shell, and this was patched previously because there was an device guard UMC bypass discovery before. So we can't create object directly. So what I thought is maybe we can use other way, and I've looked at played around with key features, and actually MS HTML restriction itself was not that hard to bypass because I've using on some specific class ID here. Basically, I used MP3 media player for detecting file presences. So using specific class ID and give a parameter value as using file URI scheme, and give a such like CMD or maybe other antivirus and other programs to detect, and this will say whether its file exists or not. So basically it's fingerprinting the file. But there was a problem because if you give a binary directory directly, it will give a prompt. It asks if this extension is executable, so you need to allow to execute. So we had a prompt before detecting the file, so I needed to discover the way to bypass this prompt. And what I came up with is using an invalid MP3 file name called console input. This console input, conin and $, this is basically a parameter inside the well-known Windows Windows function called create file. And this is reserved file name inside on Windows since Windows 8.1. So basically what this means is this console input itself is invalid MP3 file name. It's invalid, therefore it gives an unspecified error, and this will bypass the prompt and execute the script normally. So I just gave a $$.mp3 at the end, and this will execute the script normally, and it will give a file detected. And there was actually using an iframe, we don't need to execute you don't need to click on the mp3 start button, because I use some specific URI scheme called about URI scheme. This is kind of similar to data URI scheme, but if I load inside iframe, it executes automatically. And this is demo video of that. It executes normally, as you can see, and here is code of that. And I would assign CVE for this, and this has been patched actually about 2 days ago, which is Microsoft's Tuesday patch. And next theory was maybe I can play around with MP3 player ActiveX feature using and for spoofing a Windows UI and executing some arbitrary process and protocol under there. Because if you are able to spoof the whole Windows UI screen, then maybe you can do some evil stuff behind there without user noticing. So maybe that would be quite a fun idea. So I've just go and looked at specific class ID and found some nice example. And this basically uses set interval. So even you click on escape key on the top of left laptop key, usually you are not able to escape from the script. And of course you can execute via Internet Explorer too, but in this example I've shown in HTML help executable. And as you can see, full screen is all spoofed. So what happened is now, as you can see here on Twitter, suddenly pops up and pwned by James Lee. So you can just use some kind of remote code execution vulnerability while you spoof the Windows UI. And there was URI scheme called an avowed URI scheme. And this basically is similar facility to data URI scheme, because you can load crypt to top frame and you can do some fun stuff, but although it's a bit limited more. And Explorer thinks actually when you run ActiveX object with about URI scheme, it thinks it's top, which means like a nested loop. If you make a iframe inside and inside and inside, the inner iframe will reach the top side, whether how much iframe you will be using, which is same origin policy bypass. So basically we can access the top window and bypassing DOM, of course. And we need to kind of, this reference will be still alive while, for example, we can, as we move the site, if we use ActiveX object and give a self-reference, it points to the top page, but we can close that page without any confirmation as well. But after closing that browser process, the script will be still alive. So basically, for example, if you move to Google page and we close the Google page using script, using set timeout feature, but still script will be popping up from Windows UI and such weird thing can be happened. So basically using set timeout, we are bypassing the script can be dead, but we are bypassing script from dying. So script will be continuously alive while using set timeout, because if you use alert directly, it blocks the whole UI. So we can freely access the whole privilege now with the HTML file. Basically, we are making our local IP site and using local site embedding code using an iframe, and then we are using an iframe on other test site and load an about URI scheme on there. So if we see if local IP site can reach to the top page. So this is demo of that. Basically, local site will reach on the top page, which is a Google blog. In this case, if you can see. And this script will continuously pop up, and if you see here, location here points to about URI scheme, while it is actually bypassing DOM and accessing to the top domain. So this localhost is executing auto text, and it says it's the top page. And if you see here closely, some weird thing happens. Now this Internet Explorer is embedded in HTML help, as you can see, but if you wait a bit more, suddenly Internet Explorer is gone, as you can see. So I've used top reference and closed the Internet Explorer browser inside this application. So basically now this application is doing nothing, but just executing universal cross-site scripting, and then it's totally gone. But script is still alive. As you can see, suddenly Internet Explorer pops up from application, and suddenly scripts are live, while there is no browser is executing. And there's nothing in HTML help. And Internet Explorer pointed to blog, which is a top reference. So basically, Internet Explorer thinks the top page as a blog. So any questions? Thank you for listening, but I'll do some demo on the current laptop. For example, okay. This is basically the CV I got assigned before, CV 2017-11768. This basically detects the file. This is using a media player, so it's media player information disclosure vulnerability. So basically, as you've seen before this, no, I'm not gonna say source, can't say from here. So I finished off using memory corruption. user found another memory corruption inside this application, which is quite weird. Now this will execute like arbitrary processes in one shot, like endlessly, with Kark including, and it will crash cause memory corruption. And since this is not this user F3 vulnerability, but I haven't yet reported, so I'm just waiting for a demo. And thanks for watching. My name is James Lee. Yeah, I finished the demo now.